I'm Chad Reed.
I'm Hillary Langer.
I'm Gil Jenkins.
And this is Climate Positive.
For the world to meet its growing need for low-cost clean energy and achieve ambitious decarbonization targets, most experts agree that land-based onshore wind energy must be an increasingly large part of the electricity generation mix. But there's a challenge. The most efficient and cost-effective wind turbines, which we see applied only in offshore wind farms today, have enormous blades, some longer than a football field. That makes them extremely difficult, if not impossible, to deliver and deploy because, well, bridges and tunnels and road curves literally get in the way. So to explore how the onshore wind industry can overcome these obstacles and drive further growth for the sector, I sat down with Mark Lundstrom, founder and CEO of Radia. Mark is a serial cross-industry entrepreneur and MIT aerospace engineer who has co-founded companies over the course of his career that seek to bring aerospace solutions to new sectors, including biotech, telecom, and materials science. With Radia, Mark is focused on bringing these technologies to bear for the low-carbon energy transition. Radia is currently in the process of building the world's largest aircraft that will enable the deployment of the industry's biggest and best wind turbines to locations they never could reach before, and in doing so, create more clean power at a lower cost. So without further ado, I'm excited to share this insightful and inspiring conversation with Mark about accelerating the next generation of wind energy. So Mark, welcome to Climate Positive.
Thanks, Joe.
Tell our listeners, why is Radia building the world's largest aircraft?
So Radia is at its core an energy company. And what we're doing is we're enabling what we call gigawind. So imagine offshore-sized wind turbines deployed onshore. But the challenge of deploying offshore-sized turbines onshore is their size. These turbines are the size of the Eiffel Tower. The blades themselves are bigger than a football field. So onshore, it's just very difficult to transport those under bridges, around corners, through tunnels. What we're doing at Radia is we're solving that literal bottleneck, roadblock, by building what will be the world's largest aircraft, an aircraft capable of moving a 105-meter-long blade and landing on a piece of dirt within the contours of a wind farm.
Wow. All right, we're going to get into that. But before we dive into the plane, which you call the Wind Runner, give me a little bit of flavor on the origin story. You founded Radia in 2016. You came out a big way out of stealth mode in March of this year. So what's the inspiration behind the founding? Was there one of those classic back of the napkin moments, or is it, just sort of read an article and say, oh, this is a problem in the wind industry?
Pretty interesting founding experience. Basically, I had started the company exploring if there were opportunities on the interface between aerospace and energy to have a very profitable business and take out percentage points of CO2 out of the world. And around that time, shortly after I had started the company, basically a press release came out. Two arch rivals in the wind turbine manufacturing space, their chief technology offices issued a press release together. Arch rivals that compete for every deal in the world, they issued a press release together basically saying that the industry and the companies know how to make offshore-sized turbines and deploy them in places like the North Sea. But they're frustrated that they can't take that knowledge that they have and those manufacturing facilities that they have and start to make turbines that are comparable in size, but deploy them onshore where the market is more than 10 times bigger. And so this press release basically said, can an aerospace company or engineer, entrepreneur, come and help us figure out how to airlift an object that weighs, for example, 60 tons and is over 100 meters in length and landed on a piece of dirt in the middle of a wind farm? And so I showed up within a week and started working with them on
Within a
vision.
week?
Within a week, I was over in Denmark working with them on this, and and then that was a fairly clear signal that there's a gigantic market opportunity when competitors in a large industry.
Unusual.
Yeah,
you've co-founded companies across various sectors throughout your career. In addition to being an aerospace engineer, I think, does that technically make you a rocket scientist, or do you not like that term?
I guess it fits, yeah.
Okay.
And the common theme of all these companies, the common theme of all the companies has basically been bring aerospace into industries that don't use aerospace.
And was there anything about, coming out of stealth this year? I'm sure you're aware of, the power sector, huge increase in demand from data centers, AI, and electrification of things after demand was relatively flat the past 15 years. Talk about this moment, just good timing that you decided to come out of stealth when you're seeing these demands and as offshore is taking off, more blades being manufactured, or am I drawing too close of a conclusion there?
Well, there's a number of reasons that we decided to finally exit stealth. And we were in stealth for a very long time, about 7 years. And during that time, had a chance to really mature the product and the partnerships that we have. But at some point, we had to engage a larger number of companies in the supply chain, a larger number of investors, a larger number of customers. And so at that point, we decided it was time to exit stealth. And then thankfully, it actually has happened at a fantastic time, because as you know, the demands for green electrons are just skyrocketing right now, especially because of AI data centers. And so the ability to deliver these larger turbines profoundly changes the landscape for the data center world, because we can deliver electrons that are about a third cheaper, and we can triple the acres in the world where wind is economically viable with these bigger turbines. And so it was an exciting time to come out of stealth. And the way that we did it, we unstealthed both in the energy world at a couple of key energy conferences, and then also in the aerospace world at the biggest aerospace conference.
I want to come back to that at the end, both your experience at Sierra Week, the big energy show in March, and then recently at Farnborough. But let's dive into the business strategy and the product innovations themselves. So Windrunner is the world's largest aircraft, and the GigaWind, which is the ability to bring offshore blades to onshore capabilities, being delivered by the Windrunner. So first, the Windrunner, could you rip through some of the key specs of this purpose-designed aircraft? I think the little boy in me just was awe-inspired, and this is an auditory medium, so I hope our listeners will immediately Google so they can see these incredible renderings of what you're halfway through building or certifying. But give me some of the specs on what goes into the world's largest aircraft.
Sure. No, you're absolutely right. There's some great images on radia.com. But to give your listeners an idea of the specs, the aircraft itself is 108 meters long, so well over a football field in size. The wingspan is 80 meters, and it's volumetrically immense. And so it's about 12 times the volume of a 747, or about 9 times the volume of the Antonovs that are flying today. The cockpit is about the height off the ground of a 5-story building. It can carry up to a 9 meter wide payload. It can carry about 75 tons. And then one of the most impressive things about it is this world's largest aircraft can land on dirt strips. And so we don't need reinforced concrete. We've designed this so it can land on the same quality of surface as an access road at a wind farm.
Does that have something to do with the tires height, as I understand it?
This is the first time, I believe, that an aircraft has been designed to optimize around volume instead of mass. Because it's so big, we can have mini wheels, mini tires. And so the ratio of the pounds per tire is actually relatively low. And so that enables us to land on softer surfaces.
Okay, and the plan is to operate the first aircraft to deliver turbine blades before the end of the decade. What are some key milestones that lead up to that in terms of certification and so forth, test flights? Like, there's some things before the end of the decade, right?
We plan to have a vibrant business delivering turbines well before the end of the decade, and we'll be flying well before that. And you're right that between flight and business, there's some amount of certification that we have to go through. And so the big milestones that will be coming up in the next few years will be first flight, and then there'll be certification, and then there'll be blade deliveries. We have a fantastic executive team to handle all the aspects of that, from design to manufacturing to regulatory and operations. Yeah, so those are the main milestones that are coming up.
One of the things I read up on you all, your emphasis on simplicity and reliability in the design, the flight systems, ops, and manufacturing. No surprise that emphasis would ease the engineering and certification process or speed it. You're well underway. You have this engineering mantra that you gave the team as it relates to this kind of approach. Could you share that and expand from there? Sure.
So usually in the world of aircraft design, Boeing and Airbus are fighting tooth and nail over tiny incremental dollar per seat mile improvements on economics. What we're doing here is very different. And so what we wanted to do was minimize the schedule and cost and certification risks. So the marching order to the team from the beginning was design a minimum viable aircraft, maximizing the amount of reuse of components that are already flying today. And so we basically have designed an aircraft to the maximum extent possible around the things that are already certified. So like engines and flight control systems, avionics systems, et cetera. And of course, they all have to be modified to a degree, but the baseline starts with things that are already certified and already in mass production. And you're absolutely right. That allows us to minimize the certification risk when a lot of the percentage of the aircraft has already effectively gone through the certification process and already is in manufacturing.
And the mantra is do nothing new, right? Or something to that.
There's nothing new in this at all. We don't really deem this something that has a lot of technology risk. And so the mantra was, yes, do nothing new, make a minimum viable aircraft, maximize the use of things that are already in production and certified.
I love it. All right. What do you say to critics who say, building this airplane, it's impractical, even what we just said, or maybe they're like, well, why is this better than other forms of aircraft, or maybe the alternative of, hey, we can manufacture these large onshore blades at the project site with 3D printing or something because, you're trying to get around. They're too big for bridges and tunnels. But what do you say to the critics?
So first of all, it's certainly not inexpensive to make a fleet of the world's largest aircraft.
Yes.
But you have to look at it as a ratio of the investment to the market size, really. And if the market analysts are correct, we're looking at somewhere between a $5 and $10 trillion deployment of CapEx for wind turbines in the decades to come. And so that certainly justifies some significant expenditure to enable the doubling of the capacity of a wind turbine and cutting down the LCOE or the cost of the energy by a third. So the investment proposition all pencils out. Then your next question was, why not look at other forms of airlift to move these gigantic turbines? We did that from the beginning. We set out looking at helium solutions. We looked at rotorcraft solutions. We looked at modifying an existing aircraft, and none of those solutions really worked. And so then we turned to the mantra that we mentioned earlier, do nothing new, design an aircraft around existing systems that are already flying, and just have a new fuselage design, a new aircraft design, a design that's based around systems that are already in mass production today. And then with regard to your last question, big turbines are much more powerful. If you could make them in modules or if you could 3D print them, those would be interesting solutions. But as we've worked with the turbine OEMs, and we've partnered with almost all of the big ones in the world, they would strongly prefer to move single monolithic pieces to the sites. If you can transport them, they would prefer to transport something that's made in a factory and is just transported to the site in a unique way. It turns out that when you try to do things in pieces or 3D print, the structural integrity isn't there, and the segmentation or something of a blade, it's very, very difficult to segment something that's as big as a 100-meter plus object that weighs 60 plus tons.
What's a typical trip length in the U.S. from the manufacturing base of the blade? Do they have an airstrip at the manufacturing base or a place to avoid tunnels before it gets to your aircraft? And then how long does it have to go in your models?
So the operational concept is that the pickup will happen either at a factory or at a port. And so, these factories are large factories. Most of them are out in the countryside with ample land nearby, or even a local airport nearby with no bridges in between. And so there's either land or a local airport that we can take off from. And then with the intermodal ports, we've identified and have relationships with a handful of ports around the world where the port and the airport are basically co-located. And so a blade could come in from international manufacturing on a boat and then do a transfer to our windrunner at the port and then fly to most of a landmass.
I mean, the focus is blades, right? That's where the market opportunity is. But what else, other applications of cargo could you fit or we're thinking about? I think I read about, think about the applications for disaster relief. These are probably secondary markets, but what else would you throw in the world's largest aircraft down the line?
Within the wind market, first of all, there is a secondary opportunity to move tower segments as well, and sometimes other parts of the turbine. We've optimized it. We believe that the business will mainly focus on moving blades, but that we can certainly move different parts of the turbine as well. Beyond the wind industry, though, there's certainly some other huge opportunities. You're absolutely right. Disaster relief is one, because being able to land a large payload on a dirt strip that's basically prepared by bulldozers and grading equipment is a capability that could be fantastic for disaster relief. There's also some really interesting military applications. So it's a great dual-use technology with military applications. You could, just to give you an idea of the dimensionality of the aircraft, you can consider it sort of an aircraft carrier. You could put six F-16s inside of the vehicle and move that. You could put six Chinook helicopters with the blades on and land it on a piece of dirt in a foreign deployed theater. You could put the biggest rockets that are made today inside the vehicle and move them and be able to launch from anywhere in the world. So there's some fantastic military applications of this as well. And what's really surprising is that there's really no large cargo aircraft in production or planned, military or commercial, nor has there been one in production for about 15 years. And so there's this massive capability gap, both civilian and military, for large cargo. And of course, the small number of Russian, Ukrainian Antonovs that existed, most of those are now sanctioned from Western use due to the Ukraine war. So there's a giant opportunity in lots of different aspects of military and civilian cargo and wind.
Is part of your business, and then I want to move a little bit more into the GigaWind, but you have the fleet of planes, the customer, in the case of the developer, the IPP, they want the delivery of the blades. I think I read you need about 25 turbines to make it pencil. They're sort of contracting with you to do the delivery, but is the plane then available or the planes available for maintenance? You've got that tension between, well, then the next people need the plane, next developer needs it. So have you thought about the balance between, service flights to bring repairs as needed
That is one of the great benefits of having an airlift solution for blades, is that if you do have a maintenance issue or a replacement requirement, rather than having to replan road transportation for a blade, which often takes a year of planning, instead we could fly it in 4 hours. And the other thing that is interesting about the operational concept at the wind farm is there's a big industry, of course, in repowering wind farms. And right now it's really, really difficult to dispose or take out the old. You can imagine a scenario where we fly in the new and bring out the old at the same time. And that makes repowering so much easier.
The reason I thought of it was not to pick on offshore wind, but I know they need a very special type of boat for the construction of offshore. And there's not that many of the boats. And it's like, who's booked the boats that are only in Europe because there's some Jones Act? That's an issue, right? So you got to build a lot of these.
Yeah, totally. And those ships that are nicknamed jackup ships are the key. If not for those ships, offshore wind would not exist.
Right.
And if not for this giant aircraft, large format turbines onshore won't exist. And so we are at a very similar point of the value chain as the jackup ships for offshore.
Talk about GigaWind. You talked about some of the specs, or how many megawatt sized turbines. I mean, these are 10 megawatt, I think, roughly. Give me some of the specs about GigaWind.
So first of all, let me emphasize that we intend both to transport the largest turbines of today that are just hard to get to most of the places as a first step. And as a second step, we provide the industry with the ability to make ever bigger turbines up to 105 meter in blade length. If we assume that we're talking about the largest turbines that we'll be able to transport with a 105 meter blade, this gives you the ability to double or more the capacity of an onshore turbine. And so we get into the range of, depending on the capacity factor, get into the range of somewhere in the 7 to 10 megawatt. And the result of that is you end up reducing the LCOE, or the cost of the electron, by oftentimes around a 30%. You increase the capacity factor or the utilization by around 20%. And then one of the most interesting things about it is you can dramatically reduce the viable wind speed for turbines.
Yeah. And what that means is you can go on the edges of the wind corridor as it is today, right?
Yeah, you can double or triple the acres in the world where wind is economically viable. And so that's essential because you start getting away from the constraints and the concerns about crowded interconnects and transmission lines. And it gives you the opportunity to site behind the meter projects in more remote locations as well.
Climate Positive is produced by HASI, a leading climate investment firm that actively partners with clients to deploy real assets that facilitate the energy transition. To learn more, please visit hasi.com.
You're both doing the plane, but you're doing the early stage development, partnering with the IPPs, mostly US. You envision for the gigawind sites, but you said North Africa as well. Tell me about there's a great thing on your site where you can show what's expanded in terms of viable areas with gigawind, but tell me about how you're thinking about early stage development in the US and why North Africa.
So we've built a fantastic development organization that focuses right now on early stage development. And you're absolutely right that most of the projects that we're working on are in the US, and we have the capability to work on projects that are either for electrons into the grid, electrons behind the meter, and also for green molecule projects. We do have aspirations, of course, to be an international company. And so some of the first projects that we've been working on internationally are in Morocco. We have a belief that North Africa in general will be the principal source of energy of the future for Europe. And so in addition to satisfying the energy needs and energy poverty opportunities in Africa, there's a fantastic export opportunity of both molecules and electrons from North Africa into Europe. And so some of the best wind resource in the world is there. And so we're working on projects that will allow us to take advantage of that wind resource for both North African consumption and also for export into Europe.
You know, of the things that keep you up at night, do you worry about the social license to operate, the NIMBY, when you have an offshore sized turbine onshore? Personally, don't get it. I think these are awe-inspiring the bigger they are, and you can often have less of them. How are you thinking about that down the line? Is this really
any wind developer has to be incredibly sensitive to community issues. And with the bigger turbines, that's no exception, of course. You put your thumb on one of the key points, though, which is that with the bigger turbines for production of a gigawatt, you need half as many turbines.
Yep.
And so half as many turbines, it eases a lot of the siting challenges when you have so many fewer turbines. Now, there will certainly be areas that we and other wind developers can't get into because of siting issues. But if you imagine having 2 or 3 times the acres in the world that are viable, you have a chance to go and start deploying in other areas as well that might not be quite as sensitive. And then finally, I think, when I look at wind farms, if you look at the wind farms that were installed 20 years ago, the turbine's rotational speed is so much faster. I find it more soothing to have the very large turbines that have a slower rotational speed.
Yeah.
And so I think it is actually, even though you can see it from farther away, it's more pleasing to the eye than the turbines of the past.
Is there an extra level of permitting when you're needing to add a small dirt airstrip or gravel to the project site that's got some extra FAA work there?
It turns out it's actually not too bad to add an airstrip for your private use. If you're trying to make an airport for commercial service, that takes over a decade to get permitted. If you're effectively just using it for your own use, it's really not that onerous to get the appropriate approvals for constructing the airstrip and landing there.
Yeah, I imagine sometimes even the roads would be harder to some of these sites.
It's challenging when you're building a wind farm with truckable turbines, because it really does throw a monkey wrench in the logistics in a community for quite a while. And so bringing these in by air avoids all of those local challenges on the roads.
Let's talk a little bit about the customers. Your first customer is a large IPP that has bought a 1 gigawatt project in Nevada. I assume you can't talk about them, but probably fair to say you're talking to all the big independent power producers. Generally speaking, how do you think about your partnerships today with the wind farm developer, owner operators? How's it going?
Yeah, everybody in the industry recognizes the benefit of bigger turbines. And that's true for the turbine OEMs. It's true for the independent power producers. It's true for the data center and hyperscalers. And so these are all relationships that are really important to Radia. And you're right, the first sale has been to a major IPP. And it's really important for us to have tight relationships with the other large IPPs in the world. So we're developing and nurturing those. And then we have established relationships early on in the company with most of the large turbine manufacturers in the world. And so we work with
the ones who
turbine.
put out the press release. Right.
Yeah, right. And so we work with manufacturers that account for about 60% of global market share for onshore wind, and so have a pretty robust partnership with the turbine OEMs.
So speaking of customers, partners, stakeholders, you were recently at the big Farnborough International Air Show in the UK this summer. I'm a clean energy guy, but I know Farnborough quite well because it is the big show along with Paris. I started my career in aerospace and defense, so I know what a huge deal it is for visibility in aerospace to exhibit there. Tell us about the show. You made some news there that I also want to ask you about in terms of your first supplier partnerships. But what's the reaction from industry stakeholders? What was it like in Farnborough? And then maybe I'll ask you about the contrast with CERAWeek.
Farnborough was fantastic. The third major show that we had visited this year, CERAWeek, American Clean Power, and then Farnborough. And of the 1,500 companies at Farnborough, I think we were able to generate a fair bit of buzz. This is a fairly unique project in the sense that it's, one, the world's largest aircraft, and two, it's an opportunity for the aerospace industry to have exposure into energy. Yes. And so if you think about the aerospace supply chain, they usually are correlated with the airline industry and with the defense industry. And these two industries are very cyclical. And energy is not as cyclical and is not correlated really with airlines or defense. And so there's a great financial opportunity for the supply chain to work with us to get exposure into the energy world. And then furthermore, the aerospace companies and professionals that had a chance to visit us at Farnborough start to realize that as an aerospace engineer or as an aerospace company, you can be part of the climate solution. With GigaWind deployment, we'll be taking many percentage points of CO2 out of the world. And so to be an aerospace engineer and be part of that solution is a unique opportunity in one's career or for one's company.
So at Farnborough, you did announce a really important supplier partnership, right? Can you talk a little bit about that? Because that's a key milestone that will take you years from now and to certification as the supplies start coming in.
Yeah, so the key suppliers that we announced at Farnborough were Leonardo. And so it's an Italian company that is excellent for aerostructures. They do make a certified aircraft themselves. They also make lots of helicopters. Our particular interest and partnership with them is focused on aerostructures, where they'll take the lead on fuselage design and manufacturing. And then for the wings, we selected a company called Aernova. It's a Spanish company. They supply a lot of the wings for Airbus and for Embraer. So truly one of the leading suppliers in the world for wings. And by the way, Leonardo is a major supplier to Boeing, it turns out. So having companies that now basically represent most of the structure of the aircraft is fantastic to have that under our belt. We've actually signed up, but not yet announced, suppliers that account for about 80% of the total supply chain of the aircraft at this point.
And wasn't one of the CEOs of maybe the Spanish company, he knew the wind industry very well.
It was amazing. The CEO of Aernova came from the wind turbine industry. And so Spain has a fantastic heritage in wind and also in aerospace. And his career started off in the wind energy business and then went into wings in the aerospace side.
I meant to ask earlier, I assume the Windrunner will be fitted to adopt sustainable aviation fuel over time. That's important for the carbon story, I imagine.
Yeah, it turns out that in the construction of a wind farm, so even if we were using standard Jet A fuel, by delivering the GigaWind turbines, you actually reduce the total amount of construction-related CO2 because the bigger turbines, they have wider towers, they have thinner steel sidewalls, and they also have a fewer number of concrete bases. And that's where most of the CO2 comes from in the construction of a wind farm. It's either the steel or the concrete. And so we can help minimize both of those. But then you're absolutely right. The aircraft will use sustainable aviation fuel. And not only will it use it, but we have intent to help make it. Because with the bigger turbines,
green hydrogen, yeah, sure.
Yeah, with the bigger turbines, you can reduce the cost of green hydrogen by about 20% and reduce the cost of SAF by about 20%. And so we intend to be our first customer, of course, but also hope to be part of projects that will supply the industry with SAF. One more note on Farnborough, by the way, we're looking forward to the future Farnborough and Paris air shows because this aircraft will have a fantastic demo capability. So it's gigantic, but in addition, the thrust to weight ratio is similar to a fighter jet. when it's empty. And so imagine the world's biggest aircraft doing barrel rolls and things like that at Farnborough.
Yeah,
I'm not promising that, but
okay, that might make a few headlines. Just back to the carbon and the climate impact story. I think that was covered in a really interesting study looking at the economic and environmental impact of GigaWind that you commissioned from Gil Jenkins of Princeton. I think listeners can find that information there about the avoided emissions from gigawatt and Windrunner by 2034 model scenarios.
Professor Jenkins, Jesse's one of the top energy modelers in the world, and is one of the main contributors to the planning that went into the IRA. So we equipped him with some of the power curves and the features of GigaWind, and asked him to have a look at what would the impact be of GigaWind in the US. And his conclusion was that there would be hundreds of additional gigawatts that would get deployed of wind, that the cost of wind out of the grid would go down by 16%, and the emissions from the grid will go down by 15 to 30%. And so a fairly big step function, validated by his models once we get GigaWind deployed.
Tell me about the team. You've got this great leadership team, aerospace, energy experts, backgrounds at Boeing, other Embraer, Invenergy, we talked about before we hit record. What are they like to work with? What are they working on? Shout them out. I mean, this is a huge undertaking.
The executive team has been fantastic on both the energy side as well as the aerospace side. And so James Williams runs our energy development effort, a former executive at Invenergy, has developed quite a number of gigawatts of renewables in the US. And so he's taken the leadership to build up our own in-house development team, both for international and domestic development, both for electrons as well as molecules. And then on the aerospace side, let's see. So we have a fantastic handful of leaders there. To point out a few, Rachel heads up all of our engineering and development. She's our chief engineer, Rachel Kelly. She's been with us for many years, 5 or 6 years. Comes from Boeing, where she was the chief engineer on Air Force One, among other leadership roles at Boeing. And then our manufacturing headed up by Christine Block, and she comes from Embraer, where she was running U.S. operations for Embraer, and also was the manufacturing leader for Embraer's cargo aircraft back in Brazil. Mel Johnson came to us from the FAA, where Mel was basically running certification for non-Boeing aircraft. And so the majority of the people at the FAA that are involved in certification for non-Boeing aircraft were in Mel's organization. So it's been a fantastic leadership team, both for engineering, manufacturing, and certification.
Great. And you got a very strong advisory board as well, mix of aerospace, energy, and government.
Yeah. And so you can imagine, like, whether it's advice or connections, introductions, in order to pull off Radia and GigaWind, we need great connectivity, both in the aerospace world as well as in the energy world. And so having people on the advisory board on the energy side that are, former Secretary of Energy of the United States. Right. And Jason Bordoff, who heads up the Energy Center at Columbia. It's been a fantastic group of people on the energy side. And then on the aerospace side, having relationships with the former head of the FAA, former head of rocket science at MIT, the former head of commercial aircraft production at Boeing. It's been wonderful. And then we started to broaden the advisory board as well to include international leadership. And so we have aspirations for some projects in Australia, for example. And so we brought on the former prime minister with Malcolm Turnbull.
Maybe one last to close it out before we turn to our hot seat. What major milestones can we expect to see from Radia over the next few years? I wanted to ask, when it's time to do those barrel rolls in Farnborough, you're a certified pilot. Are you going to be flying the test flights, or are the lawyers and the insurance folks a little uncomfortable with that?
I'm a pilot, but just barely. So I wouldn't count on me being the one that's going to be doing
probably
the flying.
The better decision.
I certainly hope to be along for the ride, but we'll let the professionals do the flying. We do have a fantastic flight simulator now, which I enjoy flying, but we'll have some great trained pilots to do the actual maneuvers.
How is Radia looking at the massive expansion in demand and capturing that opportunity?
There's a gigantic emphasis right now, of course, on rapid deployment of gigawatts for data centers, and the amount of energy that is going to be demanded by the end of the decade just to supply data centers is about the power demand of India.
Right. It's like 9% of power
it's just
demand.
An amazing amount.
Incredible.
It's an amazing amount of new power was relatively unexpected. If you look at the power demand projections from 2 years ago, nowhere near where they are today. And so, we really hope to be able to work with that industry to be able to deploy on a global basis more rapidly, but also much less expensively. Because if you can reduce the cost of power by a third and increase the capacity factor by a fifth, it's a game changer for the data center community.
All right. You ready for the hot seat?
Sure.
Okay. So no wrong answers here. Mostly fill in the blank. First thing that comes to mind, I'll say the phrase, you fill it in. The word or phrase I try to live my life by is
creativity, passion, and creation.
The key ingredient to my productivity is
running.
The most challenging part of my job is
building an interdisciplinary team that have world-class leaders across all functions.
Best part of my job is
building an interdisciplinary team that has leaders across all functions.
Yes. The historical aerospace engineer I most admire is
Wernher von Braun.
Ah, yes. The most famous, you want to say why? For those who aren't.
There was this great story where when we were trying to get to the moon and we had the Saturn IV and there were 4 engines on the corners of a square and none of the engineers could figure out how we could get more thrust to get to the moon. And he realized there was a big gaping hole in the middle of those 4 engines for a 5th engine, creating on that whiteboard the Saturn V. Just one example of sort of his on the spot instincts and creativity.
The book that has influenced me the most is?
There's an operations management book called The Goal, which is a great book if one wants to understand the origins of lean manufacturing and lean organizations.
In your bio, I read that you were a former competitive skier. If you had to name your skiing style after a movie title, what would it be and why?
After a movie title.
Turn and Burn. I don't know if that's a movie.
Yeah, I can't. Sorry, my movie Rolodex or
Oh, give me an anecdote, like the one thing you learn from being a competitive skier that you apply today.
As a competitive skier, every course is different, and so you have to have some capabilities so you can deal with all kinds of differences, and you have to be prepared for all the different random things that can come at you. And so it's a good metaphor for life.
One last, our signature question. Finish the sentence. To me, climate positive means
massive deployment of low-cost wind around the world.
Well, I congratulate you on a fantastic first year of a launch for Radia and all that you're doing and all that you and the team will continue to do. It's really inspiring. So thank you for coming on Climate Positive.
And we'll expect you to be at the first flight.
Well, if you're doing barrel rolls. If you enjoyed this week's podcast, please leave us a rating and review on Apple and Spotify. It really helps us reach more listeners. You can also let us know what you thought via Twitter @ClimatePosiPod or email us at climatepositive@hasi.com. I'm Gil Jenkins, and this is Climate Positive.